40 million years ago, a creature the size of a school bus ruled the shallow seas of the Eocene epoch. When scientists first unearthed its bones in a Louisiana hillside, they made one of history's greatest mistakes. They didn't even know what they were looking at. It wasn't a fish. It wasn't a lizard. It was something that defied every category they tried to force it into. A predator so perfectly sculpted by evolution that it dominated an entire ocean. A creature so strange, so violent, so utterly improbable that its discovery would reshape everything we thought we knew about the evolution of whales. Its name is Basilosaurus, the king of a vanished world, and its story is stranger than almost anything in the history of life on Earth. Basilosaurus was a genus of large predatory prehistoric whales from the late Eocene epoch, living approximately 41 to 34 million years ago. It was not a dinosaur. It was not a reptile. It was, extraordinarily, a mammal, a distant ancestor of the whales that cruise our oceans today. The type species, Basilosaurus ceterides, measured somewhere between 17 and 20 meters in length, roughly the size of a school bus and a half, and weighed up to 15 metric tons. It was, by most estimates, one of the largest animals of the entire Paleogene era. And for millions of years, it ruled. But the story of how we came to know Basilosaurus is itself a tale worth telling, one of scientific confusion, buried bones, and a name that stuck despite everyone knowing it was wrong. The first bones were not found by a scientist. They were found by accident, exposed by rain sliding down a hillside thick with seashells in Wadi Parish, Louisiana. The bones lay in a curved line measuring upwards of 400 feet in length, scattered across the earth like the ruins of some impossibly large creature. Local residents had no framework for what they were looking at. Some of those bones were used as andans, fireplace tools, and destroyed forever. A Judge Henry Bry saved what he could and speculated that the remains belonged to a sea monster. He supplied fragments to anatomist Richard Harlan, who in 1834 formally described the creature and gave it the name Basilosaurus, meaning king lizard, because he was convinced it was an enormous reptile, perhaps comparable to Plesiosaurus or Mosasaurus, but even larger. Harlan estimated the animal could not have been less than 80 to 100 feet long. He was wrong about what it was. But the name survived. When Harlan brought his assembled specimens, fragments of jaw, teeth, a humerus, rib fragments, to Britain, he presented them to the great anatomist Richard Owen. Owen examined the molar teeth carefully and made a critical observation. They were two-rooted, a dental morphology unknown in fish or reptiles, and more complex than in any known reptile. This was a mammal. Owen correctly associated the teeth with cetaceans, though he initially believed the creature was herbivorous, something like a sirenian. He proposed renaming it Zeuglodon ceterides, meaning whale-like yolk teeth, a reference to those distinctive double-rooted molars. Harlan agreed. And yet the rules of zoological nomenclature are unforgiving. The original name, Basilosaurus, had legal priority. The king lizard that was not a lizard was stuck with its misleading crown forever. To understand how Basilosaurus functioned in its world, we must picture an environment that no longer exists. 40 million years ago, shallow inland seas spread across what is now the Sahara Desert and the American Gulf Coast. These warm, nutrient-rich waters teemed with life: sharks, large fish, and smaller marine mammals. Basilosaurus was the apex predator of this world, and it hunted with a body unlike anything alive today. Its form was elongated, almost serpentine, with a long, flexible spine that would have allowed it to move through shallow water with surprising agility. Unlike modern whales, which swallow prey whole, Basilosaurus had heterodont dentition, multiple types of teeth including canines and molars, meaning it could actually chew its food. It bit down, processed, and consumed. The evidence for what it ate is preserved in extraordinary detail. The smaller dolphin-like relative Dorudon appears to have been a predominant food source. Bite marks have been found preserved in the skulls of Dorudon fossils, and stomach content analysis has pointed to these creatures as regular prey. Basilosaurus likely targeted young Dorudon calves, ambushing them in the shallows. The violence of that ancient sea is written into the bones themselves. The second confirmed species, Basilosaurus isis, lived in the region that is now the Mediterranean, with fossils found across North Africa and Jordan. It was formally named in 1904 based on material from one of the most remarkable fossil sites on the planet, a place the ancient Egyptians could never have imagined, Wadi el-Hitan, the Valley of the Whales. Wadi el-Hitan is an Egyptian sandstone formation that has yielded some of the most important early whale fossils ever discovered. The German botanist Georg August Schweinfurth first discovered Archaeocene whale remains in Egypt in 1879, and by the early 20th century, researchers were beginning to understand the site's extraordinary significance. In the 1980s, paleontologists Elwin L. Simons and Philip D. Gingerich began systematic excavations at Wadi el-Hitan and the nearby Qasr el-Sagha formation, hoping to connect fossil material from Egypt with Archaeocene discoveries from Pakistan. Since then, over 500 Archaeocene skeletons have been recovered from these two locations alone, the majority of them either Basilosaurus isis or the smaller Dorudon atrox. Walking through Wadi el-Hitan today is walking through a graveyard of giants, their bones emerging from golden sandstone, frozen in the postures of their final moments, in what was once the floor of a warm Eocene sea. Philip Gingerich's work at Wadi el-Hitan became one of the most significant contributions to our understanding of cetacean evolution. His excavations helped establish the evolutionary timeline of whales, showing how creatures that once walked on land gradually became the ocean's most powerful swimmers. Basilosaurus sits near the end of that transition. It almost certainly never came ashore. It may have been among the first fully aquatic cetaceans, sometimes referred to as the pelagisti, creatures that had crossed a biological threshold from which there was no return. The vestigial hind, limbs that some Basilosaurus specimens appear to retain, are a ghostly reminder of the terrestrial ancestors it left behind, bones that served no locomotor function, remnants of a life on land that evolution had quietly archived. The scientific history of Basilosaurus has not been without controversy. For much of the 19th and 20th centuries, the genus functioned as what paleontologists call a wastebasket taxon, a catch-all category into which any vaguely similar Eocene cetacean fossil might be thrown. Dozens of species were assigned to the genus at various points, only to be later reclassified or invalidated. The confusion was compounded by the initial misidentification as a reptile, by incomplete fossil material, and by the sheer strangeness of the animal itself. Even today, only two species are confirmed, B. Ceterides and B. Isis. The rest have been reassigned, their identities clarified by more rigorous analysis and more complete specimens. There is something deeply human in the story of Basilosaurus. When those first bones slid out of a Louisiana hillside in the early 19th century, the people who found them had no context, no framework, no language for what they were seeing. They built fires with the bones. They told stories about sea monsters. And in a sense, they were not entirely wrong. The creature those bones once belonged to was monstrous, ancient, and alien to anything in their experience. The history of paleontology is a history of ordinary people stumbling across extraordinary things, and then the slow, painstaking work of science making sense of them. What Basilosaurus reveals about evolution is both humbling and exhilarating. Here is a creature that bridges worlds, a mammal that breathed air, that may have nursed its young, that carried within its elongated body the faint skeletal memory of legs it no longer needed. It is a monument to the relentlessness of natural selection, to the way life will fill any available niche, reshape any body plan, cross any boundary. The whale's return to the sea is one of the great narratives of evolutionary biology, and Basilosaurus is one of its most dramatic chapters. Today, Wadi Hitan is a UNESCO World Heritage Site, protected precisely because of its irreplaceable fossil record. Researchers continue to excavate there, and every new specimen adds texture and detail to our understanding of Basilosaurus and its world. Modern imaging technology allows scientists to examine fossils in ways that Richard Owen and Richard Harlan could never have imagined, scanning bone structure, analyzing isotopes, reconstructing the chemistry of ancient seas. Each new discovery refines the picture. And the questions those discoveries raise reach beyond paleontology. As we watch modern whale populations decline under pressure from human activity, climate change, and habitat loss, Basilosaurus offers a sobering perspective. The Eocene sees that this creature ruled were themselves subject to change. The cooling of global temperatures at the end of the Eocene contributed to major shifts in marine ecosystems. Basilosaurus vanished. The world moved on. New forms arose. The lesson is not comfortable, but it is clear. Dominance is not permanence. The most powerful creature in an ocean can disappear when the ocean itself changes. 40 million years from now, if anything is left to look, the bones of our own era's giants may lie in formations not yet named, waiting for some future intelligence to piece together what we were, what we ruled, and what we failed to protect. Basilosaurus, the king lizard that was never a lizard, the whale that looked like a serpent, the apex predator of a vanished sea. It endures now only in stone and in the deep evolutionary memory carried forward by every whale alive today. That is legacy enough for any king.